Thunder thighs. I mean, that phrase alone, it's got some real impact, doesn't it?
It really does.
It makes you immediately wonder, like, what kind of creature gets a name like that? A defining feature right in the name.
Mm-hmm.
Well, that's what we're digging into today. We're talking Brontomerus.
Exactly. And Brontomerus, well, it translates pretty directly from Greek, thunder thighs. And the fascinating part is this isn't just, a cool nickname someone came up with later.
Right.
The fossil evidence, even though it's a bit limited, it really does suggest this dinosaur earned that name.
Okay, so what evidence are we working with? What's the source material for this deep dive?
We've got the original scientific paper, the one that first described Brontomerus back in 2011. And then there's some later research analyses that have tried to place it more precisely and figure out what it was doing.
So the big question for us then is, what makes Brontomerus so interesting scientifically, especially, the whole thunder thighs aspect, and what can we actually piece together about its life?
That's the goal, to explore the science behind the name and the different ideas about how it lived.
Okay, let's start at the beginning. Where and when did this dinosaur actually come to light?
Right, so the fossils were found in eastern Utah. They come from a specific layer of rock called the Ruby Ranch Member.
Okay.
And that layer is part of the bigger Cedar Mountain Formation, which is a really famous spot for dinosaur finds from the Cretaceous period.
Cedar Mountain, yeah, I heard of that one. And what exactly are we talking, time-wise?
We're looking at the lower Cretaceous period, specifically the Aptian or Albian age. So roughly, give or take, 110 million years ago.
Wow, 110 million years. It's always staggering. So the actual discovery, it wasn't like one person just stumbled upon a whole skeleton.
No, not quite like that. The actual bones were collected back in the mid-90s.
Oh, earlier than the paper then.
Yeah, 1994 and 1995. Researchers from the Sam Noble Museum picked them up, but it took a while before they were formally studied and named. That happened in 2011.
Right, you mentioned 2011 by Taylor, Wadle, and Cifelli.
That's them. Michael Taylor, Matthew Wadle, and Richard Cifelli. And the full name they gave it is Brontomerus mackintoshi.
Mackintoshi. Does that part mean something specific too?
It does, yeah. It's an honorific. It honors John Stanton McIntosh. He was a physicist, actually, but also a huge expert on sauropods, especially North American ones.
Wow. A nice tribute then.
Definitely. A nod to someone who contributed a lot to understanding these giants. But finding these particular fossils, it wasn't straightforward, was it? There were some issues at the site itself.
Yeah, reading about it, it sounds almost like a bit of a paleontological tragedy, really. The sources mention pillaging at the Hotel Mesa Quarry, where they found Brontomerus. Apparently, private collectors got there before the museum team did a full excavation.
Yeah, it's a really frustrating problem in paleontology. You find a promising site, but someone's already been through maybe taking the best bits or just disturbing things.
So that directly impacted what we know about Brontomerus.
Absolutely. It's likely one reason why the remains we have are so fragmentary. And worse, some reports say that bones left exposed at the site were actually damaged, even used like weights for tarps or something.
Oh, that's awful. Just wow. Okay, so despite all that, what did the scientific team manage to recover? What bones are we actually talking about?
Okay, so what we have comes from two different individuals. Based on the size difference, the thinking is one was a juvenile and the other an adult.
Okay, two specimens.
Right. And the most important piece, the one that officially defines the species, that's the holotype, is the left ilium from the smaller one.
The ilium, that's the big hip bone, right?
Exactly. The main broad bone you feel at your hip. But they found other bits and pieces nearby, too.
Like what else? Give us the inventory.
Okay, let's see. There was a crushed centrum from a vertebra, probably from the back or neck area, so a presacral centrum. Then several tail vertebrae, caudal vertebrae. Also a rib from the right side, a pretty big shoulder blade, the scapula, and parts of two sternal plates. Those are bones from the chest area.
Okay, so a scattering of parts. Definitely not a complete skeleton, but some key elements, especially that hip bone and the shoulder blade.
Precisely. It means there are significant gaps. When scientists try to reconstruct Brontomerus, figure out its overall shape, they have to rely quite a bit on comparisons.
Comparisons with what? Other related dinosaurs?
Yeah, with more complete sauropods that seem to be relatives. Something like Carnosaurus is often used as a reference point. It helps make educated guesses, but you always have to remember parts of the reconstruction are, inferred.
Makes sense. But even with these fragments, could they estimate the size? How big was this thunder thighs dinosaur?
They could, yeah. Based on the bones they have, particularly comparing the adult and juvenile material, The adult Brontomerus was probably around 14 meters long.
14 meters? That's what, about 46 feet?
Roughly, yeah. And weight-wise, maybe in the ballpark of 6 tons. So a decent-sized sauropod.
And the smaller one, the juvenile?
Considerably smaller, maybe about a third of the adult's length. So 4.5 meters, something like 15 feet.
Yeah.
And maybe around 200 kilograms. Still pretty hefty for a youngster.
15 feet. Yeah, not
Yeah.
exactly tiny. And I think I read somewhere there was speculation about the relationship between the two.
There was. The original describers, Taylor and colleagues, they floated the idea that given the size difference and finding them close together, the adult might have actually been the mother of the juvenile.
Oh, interesting. Like a little family snapshot.
Potentially. It hints at maybe some parental care or social structure, but, it's impossible to prove just from the bones found like that.
It's a reasonable hypothesis, though.
Oh. Okay, let's get to the main event then. Those thunder thighs. What is it about that hip bone, the ilium, that's so special?
Right. This is really the core of the Brontomerus story. The ilium is just shaped differently. It's described as being unusually deep, like tall from top to bottom.
And crucially, the front part of the ilium, the bit that projects forward ahead of the hip socket, is way bigger proportionally than the part behind the socket.
Bigger in the front.
Huh.
And that specific shape tells you something about the muscles.
It tells you a lot about the muscles. That large forward projecting area provides a massive attachment point for thigh muscles, specifically the muscles that pull the leg forward, the protractors. The inference is that Brontomerus would have had, proportionally speaking, the largest thigh muscles of any known sauropod.
Wow. The largest.
Proportionally.
That's the conclusion based on the bone shape. So thunder thighs isn't hyperbole. It's rooted directly in the anatomy we can see.
That is genuinely remarkable. Okay, so if it had these incredibly powerful leg muscles, what on earth was it doing with them? What are the theories?
Well, there are a few really interesting ideas. One of the main ones, proposed by Dr. Michael Taylor, one of the original authors, is that those muscles were built for kicking, delivering really powerful forward kicks. Kicking. A sauropod kicking. That's not the image I usually have.
Me neither. But the logic is based on where the muscle attachments are largest. It suggests strong protraction, moving the leg forward forcefully, maybe more so than retraction, which is pulling the leg back, like for running fast.
Okay, so if it's kicking, who or what is it kicking?
Could be a couple of things. Maybe other Brontomerus, fighting over resources, territory, mates, that kind of stuff.
Right, interspecies rivalry.
Exactly. Or perhaps more dramatically, it could have been defense. Think about the predators around at that time in that place. You had things like Utah raptor, Deinonychus.
Oh, yeah, big, nasty dromaeosaurs. Raptors.
Right. Maybe a swift, powerful kick from a multi-ton Brontomerus was a pretty effective way to tell a pack of raptors to back off.
That paints a very different picture. A much more dynamic sauropod. But that's not the only idea, is it?
No, definitely not. Another suggestion, this one more championed by Dr. Matthew Waddell, another of the authors, focuses on the environment. The rocks Brontomerus was found in, the Ruby Ranch member, they suggest the terrain might have been quite hilly, maybe less flat and swampy than we sometimes imagine for sauropods. Perhaps drier, too.
So the muscles were climbing.
Kind of, yeah. Or just navigating that rougher, uneven ground. Waddell called it a sort of dinosaur four-wheel drive.
Yeah.
Extra power and stability to handle slopes and tricky terrain.
A prehistoric ATV. I like that image, too. Any other contenders for the mighty thighs?
There's another possibility linked to different muscle groups. That big ilium also provides a lot of surface area for abductor muscles.
Abductors. Those move the leg outwards, away from the body.
Exactly. Strong abductors would be really important for just basic stability in such a large animal, but it also opens up some more speculative ideas.
Like what?
Like maybe Brontomerus could occasionally rear up on its hind legs, or even manage short bursts of walking bipedally. Strong abductors would certainly help stabilize it in that kind of posture.
A sauropod walking on two legs, even briefly, that's wild.
It is pretty out there, but the hip structure doesn't necessarily rule it out. And then there's one more, slightly less favored idea.
Go on.
That maybe the muscles were needed to control unusually long legs. We don't have the leg bones, remember?
Right.
But the shape of the scapula, the shoulder blade, might hint at longer forelimbs. If the hind limbs were also very long, you'd need powerful muscles just to coordinate them. Think maybe giraffe-like proportions.
Interesting. But you said less likely.
Yeah, the evidence for that one is considered a bit weaker compared to the kicking or terrain ideas.
Okay, so we've got kicking, four-wheel drive, maybe occasional bipedalism, It really shows how one unusual bone can spark so many functional questions. What about its place in the grand dinosaur family tree? Was it easy to classify?
Not entirely straightforward at first. The initial analysis back in 2011 placed it as a basal symphospondyle.
Diesel symphospondyle. Okay, break that down a bit.
Right, so Titanosauriforms is a huge group of sauropods. Symphospondyle is a major subgroup within that, leading towards the giant titanosaurs. Basal just means it's an early primitive member of that group.
Got it. Early cousin of the really big guys.
Pretty much. But the first analysis had some uncertainty. It showed what's called a trichotomy, basically. It couldn't resolve the exact branching pattern between Brontomerus, another sauropod called Euhelipus, and the main Titanosauria group. They formed an unresolved three-way split.
So, a bit fuzzy on the exact relationships initially. Did that cause any debate about whether Brontomerus was even a valid species?
It did, yeah. A year later, in 2012, another researcher, Michael Diemick, published a paper arguing that Brontomerus might be what's called a nomen dubium.
The dubious name.
Essentially, yeah. Meaning a scientific name whose validity is doubtful. Diemick's point was that the holotype, that single left ilium, might be too fragmentary or not distinct enough on its own to securely anchor a whole new genus and species.
Okay. But did he disagree with where it fit generally?
No, even Diemick still considered the known fossils to belong somewhere within Titanosauriforms. His argument was more about whether that specific hip bone was diagnostic enough to name a species.
Interesting distinction. So, where has the consensus landed since then?
Well, a study in 2013 by Mannion and colleagues took another look. Their analysis found that, yes, Brontomerus could be confidently placed as a basal symphospondyle, even if its precise relationships within that group remain a little unclear.
Okay.
So while there was that initial question mark in the nomen dubium proposal, later work seems to have generally solidified its position as a distinct early member of this important sauropod lineage.
Fascinating how the picture gets refined over time. So let's try and pull it all together. What's the lasting impression of Brontomerus given everything we know and don't know?
I think the original description really nailed it. Unusually athletic for a sauropod. That unique hip bone is undeniable evidence of some serious leg power, something different from many of its relatives.
Right.
But, as the original authors also pointed out, without more bits especially, more of the pelvis, the femur, the thigh bone itself, and maybe the upper tail vertebrae where other leg muscles attach, it's really hard to say definitively what the functional significance was. The kicking, the terrain handling, they remain strong hypotheses based on the available evidence.
So thunder thighs gives us this incredible clue, this hint of a different kind of sauropod lifestyle. But the full story still needs more fossils.
Exactly. It's a tantalizing glimpse.
Okay, as we wrap up this deep dive, let's quickly recap the absolute must-know points about Brontomerus.
Sure. Well, first, obviously the name, thunder thighs. It's not just catchy. It reflects the scientific interpretation of its unique hip bone, pointing to massive thigh muscles.
Got it. Name reflects the science.
Second, its location and time. Found in Utah's Cedar Mountain Formation, dating back about 110 million years ago in the early Cretaceous.
Okay, context is key.
And third, those fascinating hypotheses about why it had such powerful legs. Was it kicking rivals or predators? Was it like an all-terrain sauropod navigating hills? Or maybe even briefly rearing up? It suggests a potentially more active, dynamic life than the standard sauropod image.
Definitely shatters some stereotypes. And of course, we have to acknowledge the gaps, right? The fossil record is incomplete.
Absolutely. Paleontology is always ongoing. Who knows what future discoveries might tell us about Brontomerus? Maybe someone will find a femur one day.
Wouldn't that be something? It really makes you appreciate how even fragments, bits and pieces from millions of years ago can launch such intense scientific detective work. And it really sparks the imagination about the sheer variety of life back then. Thinking about how specific anatomical features like those thunder thighs are these amazing solutions that evolution came up with to meet specific challenges or opportunities in an environment.
Perfectly put. Brontomerus is just a fantastic example of that. A reminder that evolution could produce things we might never expect, like a giant long-necked herbivore that just maybe packed a truly thunderous kick,